Welcome back to session 7 of the exam prep. I'm going to start here. This starts at question 18 on the download sheets, where we got problems. Given the following problems, calculate distance, displacement using a scale drawing where it's required. And if you look at the questions themselves, which we've got over here, we said a ball is thrown. Now, what do we do first? We do a drawing. Remember, I keep preaching it, but in mechanics especially so, you will find that it helps, okay? And no, it doesn't have to be an artistic arrangement. Just do a drawing. Let's have a look. A ball is thrown from a rooftop 30 meters above the ground. Okay, so what have we got? We've got this, correct? Right? We have got a rooftop, and we know that that is 30 meters above the ground. And we know that we're throwing a ball upwards, right? And what happens when a ball goes up? What goes up must come down. So the ball is going to go upwards, isn't it? Okay, and it goes up and then it turns and comes back down. I always split it into two pieces, up and down. Because then it just tells me exactly where I am and what I'm doing, and I don't get confused by trying to do two things at once, okay? I'm always now in control of my own. Either I'm going up or I'm coming down, and that tells me exactly what I need to know. So I say, right, it's thrown from a rooftop, and it's caught by the same person on the rooftop, okay? All right, and they say, calculate the distance and the displacement of the ball. Right. So we need to say the ball is going up and the ball is then going to come down. How do we do that? Well, what do we say? Okay, the ball is going to go up, all right, and they tell us a ball is thrown upwards for 10 meters, okay? All right, the ball is thrown upwards for 10 meters. Now, then it comes down, and in case 1, what happens in case 1? In case 1, the ball comes down like so, and the person over here catches the ball again, right? So the ball went up for 10 meters, and then how far? It went down for 10 meters, didn't it? So in this scenario, the ball went up 10, down 10. How far did the ball travel? Because that is the distance, is it not? Distance is equal to 10 up plus 10 down. So the total distance is 20 meters. But the displacement, where's the origin? The origin is my hand when I threw the ball up, isn't it? So the origin is here. It's kind of like X marks the spot. The origin is there where the ball left my hand, is it not? Because if you take a ball and you throw it up, at the point it leaves your hand, that's the velocity that you've thrown it up with. So what do we say? We say, okay, the displacement is the distance moved from the origin. How far is it moved from the origin? Well, quite simply, the origin, it went up plus 10 minus 10, so the displacement is 0 meters. Correct? So all you do is just do a little drawing and then just apply the bit of logic to it, okay? Then they say, in the same, it's thrown upwards for 10 meters as before, but the ball falls to the ground, okay? So let me redraw it using a red. In this case, the ball does this, does it not? Boom. And it hits the floor down there, correct? Let me just put the floor. So what do we say? Right. Now, once again, let's have a look here. Let's put it in red, shall we? Just for the heck of it. Let's put, what is the distance? The distance it traveled, it went 10 up, right? Let's go. We went up for 10. Then we came down 10 plus 30. So we've actually traveled the distance of 50 meters, have we not? We've traveled 50 meters. We went up. So once again, can you see how valuable the drawing is? You can actually track it on the drawing. So we say it went up 50, up 10, down 10, then we're there. That's 20 and 30, so it's 50 meters in total. Okay, what do I do next? Is displacement. Okay, let's say up is positive. Okay, upwards is positive. Therefore, plus 10, which means down is negative, minus 10, plus 10, minus 10, and then minus 30. So my displacement is minus 30 meters, right? My displacement is minus 30 meters because I'm 30 meters from the origin. Can you see that? I am 30, I know I've drawn it at an angle. I'm 30 meters from the origin. That's where the ball ended up, okay? Then they say, in number C, a map shows the following directions, all right? And they've given us some, let's just have a look, get myself back. They've said, shows the following through an obstacle course from A to B. Okay, 15, blah, 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 blah. Use a scale drawing of 1 centimeter equals 10 meters. So what do? We say, right, 1 centimeter equals 10 meters. Now let me go ahead and draw it. Okay. By the way, instead of the 30 meters negative, you could also have said 30 meters downwards, as long as you give the direction. Because displacement is a vector, it's got a magnitude and a direction. We have to tell the people where it is, right? Let's now have a look at this problem. This is question 19. Question 18C. A map shows the following directions through an obstacle course. Let's just move it up. We say, right, okay, 50 meters east, 10 meters north, 30 meters north, west, and 20 meters southwest. Used a scale drawing of that. Right. So let's have a look. 1 centimeter equals 10 meters. So I put my scale down. This is question C. And let's start, right? So what do? We first of all start from 50 meters east. Now let's just check. North, south, east, west. So first of all, we went 50 meters to the east. And they say 1, 2, 3, 4, 5. There we go. 50 meters is then going to be 5 centimeters. Remember, you put in what you know, x, and cross multiply. 10x is equal to 50, x is equal to 5, and it's the scale of centimeters is the unit, right? So that's our first one, is to there. The next is we're going 10 meters north. So we're going to go up. That's 1, 2, 3, 4, 5 is to there. And we're going to go up by 1, right? Let's just move it down a wee bit here. So we're going up by 1. That's our next vector. Oops. That's our next vector there. That is 1 centimeter, representing 10 meters, correct? Then we're going to go 30 meters northwest. Okay. Now I have to work it out. Which way is northwest? It's at 45 degrees, isn't it? So I'm going to be drawing up here, okay, at 45 degrees from there, right? I have to go up over there, okay, like so. And I'm going to draw that line 3 centimeters, 1, 2, 3 centimeters long, right? So that's my next one. Can you see I've gone northwest, right? Because northwest is there, isn't it? At 45 degrees, right? So I now move my reference point. In other words, I move the point to the end of the last arrowhead. That's where I'm going to go to put the next vector in, isn't it? Okay. I'm going to go to we always go to the end of the arrow or the last arrowhead, and that's where we start for the next one, measuring the angles, etc. And the next one is 20 meters southwest. So I'm now here, and I'll just change color quickly to, let's say, blue. And I'm now going to go from here, okay, 20 meters. Let's say 10, 20 is, say, there, all right? Let me just wipe this out here, like so. And I have scaled that off. Oops. That's going to be 2 centimeters. 1, 2 centimeters takes us to there. And this angle is at 45 degrees because that is southwest. Therefore, my resultant that I have to find is from the origin to, and let me use a straight line for that. All right. Okay. There. All right. So let's just go back to where we were. This is my, and I measure it. How many centimeters is it? I measured it here, and I said it comes out, the displacement comes out to be 2.4 centimeters. So I say 2.4 centimeters is going to be equal to 24 meters. And at 45 degrees or meters, and it's going to be northeast. Because I measure the length and I measure the angle over there. Okay? All right? So that's what I measure. Okay? Now, obviously, there's accuracies and things like that. What is the displacement of this? How do I work it out? Sorry, not displacement. How do I work out my the distance? This is, delta x is displacement here. So what do I work out for distance? How do I work? The distance is the total amount. Just think of it. How far did you walk through the obstacle course? You walked a total of 50 meters plus 10 meters plus 30 meters plus 20 meters. So you walked a total of 110 meters. Whereas in actual fact, you could have done the same if you'd have taken a different direction, northeast. But you might not have been able to get through there. There might have been a solid wall in between that you had to go around the obstacle course that way. Distance, displacement, okay? So let's just keep those in mind, okay? Because now the next question we're going to be doing is we're going to be looking at, let me just page back, okay? Question 19, right? Now question 19, we often talk about the following, right? Question 19, we often talk about speed, and often we talk about velocity. Okay, what is the difference? Well, we know that speed is distance over time, and velocity is displacement over time. Both are measured in meter per second, aren't they? Why? Because we measure distance in meters and time we measure in seconds in physics that we're doing here. So what's the difference? The difference lies in the distance and the displacement, doesn't it? So therefore, when we now talk about it and they say what is meant by average speed and average velocity, right, we can actually take the definition straight out of the book. Speed is total distance over total time. Okay, average speed. Total distance over total time. Okay? And this one is displacement over the time. All right? Once again, total time. This is delineated as delta x over delta t. All right? And this is total distance over total time. In other words, that's for the whole journey, right? Remember, you could have individual speeds for parts of the journeys. Okay? Always, when we're doing this, like I've said before, make a drawing. In other words, split it up. In physics, we cut things up into essentially time increments, right? When we're talking about mechanics, we are looking at what is happening in between this time and that time, and that time and that time, because things are going to change, and they change relative to time. Temperature versus time. As we're heating something up, so the temperature rises over time. Electric current flowing versus time. Chemical reactions, concentrations versus time. So we're looking at most of the work in terms of the x-axis being time. Okay? So in this case, we're looking at it versus time as well. And we cut it up into the bite-sized chunks that we can deal with. All right? Okay, so we've looked at that. Now, we're going to have a look at this one now again. We say, calculate the average speed and average velocity in the following. The ball is thrown up and caught by the person to blah, blah, blah. All right. let's have a look at question number 20, shall we? All right. Okay, let's just put another page there. Okay, so this is question 20. It's question 20A, where we say, calculate average speed, average velocity in the following situations. Question A ball is thrown vertically upwards to a height of 20 meters. So what do? So how high did it go? 20 meters and 20 meters. This is the upside. This is the downside. So it went up, right? And I caught it when it came down. I threw it up 20 meters high and it came down to me. So we say, right, what is then, and it took 8 seconds, right? So when they say it took 8 seconds, what are we saying? We're saying it took 8 seconds from when it left my hand until it got back to my hand. This is also called time of flight, the flight time. That's how long it took while it was in the air, all right? So what it means is it then means that how long up? 4 seconds? 4 seconds. Because it goes up and down and it's split evenly. You will see in a few minutes that this is a parabola and this is an axis of symmetry. It goes up, that's where it comes from. What goes up must come down, right? So it goes up in that general shape, okay? So we say time of flight, okay? So now a ball is thrown vertically. Calculate the average velocity and average speed. So we say, right, average speed, convert everything to meters and seconds. Remember? Meters, seconds, kilograms. We are doing physics, chemistry, decimeters cubed for volume, right? Average speed, right, is total distance is 40 meters over 8 seconds, right? So therefore, we just say 40 divided by 8 is going to be equal to 5 meters per second. Average velocity, delta x. What's delta x? Delta x is displacement, is 0 over 8, which is 0 meters per second. So the average speed is 5 and the average velocity is 0. It's the way we are measuring it. Okay, let's have a look at the next one. Right. Question B. Right. Let's have a look at question number B. Okay. B. We say a plane flies from point A to B, a distance of 500 kilometers. Okay. A to B, 500 kilometers. Can you see? I haven't even read the question. I'm just making the drawing and putting all my information on the drawing. I'm doing my preparation work, right? Okay, A to B distance of 500. The total return trip took 2.5 hours. So what are we saying? I just take a different color pencil and I'm going to say the total return trip, which means from there to there, trip time was 2.5 hours, right? Calculate, just get my color back. They say calculate in kilometers per hour the average speed. Total distance over total time. What's the total distance? 500 there plus 500 back, because I went there and back. Look how the drawing helps. If you're trying to remember this in your head, the chances are that the 500 stays in the head. You don't think about it as 1,000 because you're not seeing the picture. Remember, picture's worth 1,000 words. Over and time 2.5. That's 1,000 divided by 2.5, and you're going to go to your trusty old divided by 2.5, and my answer is 400 kilometers per hour. Okay, that sounds about right for a plane, doesn't it? Now what is the next one? The next one they say, all right, then what's the average velocity? The average velocity is displacement. Displacement, once again, is 0. 0 kilometers per hour. All right? Question C. All right? A cyclist has the following details about the trip from A to B. Distance traveled, 25 kilometers. Guess what I'm going to do? Make a drawing. Yep. Okay, so he went from A to B. Oh, and by the way, when you do the drawings, don't put B over there. Okay? Give yourself space. We're going to be getting into drawings involving strings and pulleys and all sorts of things. Learn to give yourself a bit of space. Obviously, within reason, but the reason being is you're going to be putting onto your drawing the information that you've been told. Then you're going to have to split it up possibly in chunks, okay, because things are going to change during the trip or the journey. Okay, let's have a look. It says here, from A to B, distance traveled is 25 kilometers, all right? So here we said distance equals 25 kilometers. Why did I not put that on the drawing? Because the drawing that I use, I do a straight line. Because they say the straight line distance from here to here is 20 kilometers, okay? And the time taken, time is 1 hour. Okay? Right, it takes 1 hour. So let's just work out. The average speed is distance. Okay. I haven't said whether it should be in kilometers per hour. Let me just see what I did in my answers. All right. Meters, I changed it to meters per second. Well, how do I change 25 kilometers? How do you do it? You say, right, it's 25 times 1,000, right? Use that thing that I did in the beginning is 25,000 meters. 1 hour is 3,600 seconds. Average speed is 25,000 divided by 3600. Okay? Because that's the distance. What actually did he do? He did this, didn't he? In actual fact. The guy did actually that. Okay? He went 25 kilometers actually. So therefore, the average speed is distance over time, and 25,000, 3,600 is going to be 6.94 meters per second, or ms minus 1. Average velocity. Velocity is displacement. What's the displacement from the origin? Is 20,000 divided by 3,600 is going to be 5,56 meters per second. Okay? So that's your average velocity and your average speed. The last one is question D. A balloon drifts from A to B as shown. Here they've given us a drawing. So let's just have a look at it. This is question D. Okay. A balloon drifts from A to B as shown, right? And they tell us that this is 500 meters, right? And they tell us that that there is 100 meters, right? There we've gone there, and there we've gone there. All right? So this is 250, and this is 250 meters, like so, right? It travels at an average velocity of 10 meters per second. So they've told us average velocity equals 10 meters per second. Therefore, delta x over delta t is equal to 10. All right? It was spotted over position C as shown. Calculate the average speed if it flew in a straight line A, B, and BC. Okay, I mean it's AC and BC. Sorry, I've got a mistake there. It's AC and BC. Okay, in other words, it flew AC, and then I should probably say CB, shouldn't I? Okay, so what are we saying? We're saying that the average velocity is displacement over time. Therefore, delta x is 500 over delta t must be equal to 10. Therefore, delta t is equal to 50 seconds. Right? In other words, the time it was in the air is 50. Then I say average speed is going to be distance over time, which is 50 seconds. But what's the distance that I traveled? The distance I traveled is actually going to be there to there and then there to there, isn't it? So I am traveling the hypotenuse, which means I've got to work out distance. Right? The distance is going to be, you've got to use Pythagoras. So it's going to be 250 squared plus 100 squared to the power of a half. In other words, the square root. And that's 269.3. Can you see? Therefore, it's going to be times 2. Isn't it? That's the distance I traveled. And the total comes to be, I didn't work that out, but let's see. 269.3 times 2 is equal to 538.6 meters. Therefore, let's finish off what we started. All right. It's the distance is 538.6 divided by 50, which gives me an answer of 10.8 meters per second. And that finishes off that one. All right. We're going to move on with question 21, 22 in the next session. I think I have gone a bit over, but I did want to finish that. Okay. We'll carry on with more and more of these, and we'll talk about them as we go. Thanks for watching. Cheers. Hopefully you'll see you in the next one. Bye.